first step of this module is to turn on power to the laser and photodiode detector. The laser is right here, and the power switch is on the back, but don't turn it on until it's in position. Don't be waving this thing around. It's just a heenie, it's not going to hurt you, but regardless, you want to have it in position here. And again, don't forget to turn on the photodetector. The laser light will at first impinge upon the wooden block that contains the photodiode detector. It looks a little bit brighter than it really is, and that's just the video doing that. And what you want to do is move it into position such that the light is impinging upon the photodiode. Now the Logger Pro software needs to know to look at the right instrument, and to do that you tell it to ignore any other instruments it thinks it might be reading and tell it instead to look at the instrument amplifier, and that's the photodiode. I don't know if you can probably see this from the video given the video quality. Just follow the instructions in the manual. They're accurate, they work. Again, you want the instrument amplifier, and just like when you were in LabWorks, when you got it right, the readout from the instrument will appear there on the lower left. There we go, and that's from the photodiode. Next thing is to align the laser, and this is actually oddly tricky. You can move it forward, backward, you can raise it up and down, and as you'll see in one moment, you can twist it as well. What you're trying to do is optimize the readout from the photodiode, which you just see there on the computer, and you want to get that between about 700 to 1000 millivolts. Do not go above 1000 millivolts. Note right now you're just practicing. One of you should be preparing a solution, and the other laser person needs to get used to the laser and practice alignment. Now, when it comes to the sample cell, what you want to do is make certain that the flats are on facing the laser and photodiode detector, and make sure that the laser ultimately passes more towards the front of the cell, not the middle, more towards the front and not the back. That's because of the way you flash the solution. Here's a funny thing. The potential has dropped, and that's because the sample cell has altered the path of the laser. Again, practice. Realign, get the potential back up. That's what I'm doing here. So after the laser's on and aligned, you do need to wait about half an hour, and here's why. There's actually a lot of fluctuations to the laser power at first. We promise that if you're patient, wait about a half an hour. These will steady out, and you'll check for that later. Alright, now let's get ready to make the solutions. You need a volumetric flask and a glass stopper, and we're going to weigh out some benzophenone right now. We're not going to be very specific about how this part works because there's actually many versions of this lab that all use different compositions of solution. Benzophenone, base, solvent, they're all different. In this particular case, we're developing a module, so we've biased this towards one of the modules that looks at the effect of viscosity rather than pH. So we've weighed out some benzophenone, and we're adding that to a volumetric flask here. Now, we taught you as freshmen how to correctly formulate a solution and prepare it. We're counting on that knowledge. For example, here, do not try to fill a volumetric flask from a liquid in a 4-liter bottle. That's not going to work out too well. Instead, fill a beaker with a little bit more than you think you need. And it's actually slightly difficult to fill a volumetric flask from a beaker, so we're using a funnel as here. Again, the volumetric flask has the benzophenone, and benzophenone can be somewhat difficult to dissolve. It takes a while, so you don't fill up the volumetric flask all the way. You can't really mix it here. So here we're swirling it around, and you will probably have to use the sonicator as well. Make sure you cap it before you put it in the sonicator. Alright, once the benzophenone has dissolved, we take the volume to the line with a pipette. Got to do that carefully, stopper it, and mix it well. Now in the version of the lab that we're showing, you're going to add 1 ml of a KOH solution. That's just the version that we're showing right now. But here's the important thing. When benzophenone is mixed with aqueous base, it's a time bomb. It's massively light sensitive. Do not mix them unless you are in the dark room with the red light on. You probably can't see this in the video. It's too dark. Your eyes will adjust. You'll be able to do it. What the TA is doing now is adding the base to the benzophenone solution and mixing it. The next step is to fill up the sample cell, which you probably can't see here. You're going to use this little syringe tool that we made to stick the needle part into the sample cell, and you just fill up the syringe part with the solution. It's a little slow, but it's easier to use this in the dark. And here we're going to turn on the light so you can see this a little bit better. Don't you do this. If you do this, you just ruin your solution and you're back to square one. Again, it is a little slow, but it does make it easier to deal with the thing in the dark. You want to fill this to, you don't want to fill it up all the way. You want to fill it up to maybe 2/3, maybe 3/4 the way from the top. That way you're certain that the laser will pass through the solution when you set that part up. The next most important thing is once you've filled the sample cell, we're going to go back to the dark here in a second, what's happening is that the long needle, which is called a cannula, has been submerged in the solution and is bubbling nitrogen to get rid of oxygen. Light's on so you can see it. So here's the cannula in the solution. You want it to bubble fairly violently, but you don't want it shooting out of the sample cell. And you're going to control the degree of sparging with the little valve right here. Be very careful with that. It's kind of high pressure nitrogen. You must do this for 15 minutes. If you do it for 14 minutes, I guarantee you the solution will not work and you're going to have to start over. 15 minutes. After 15 minutes, what's happening here, I know you probably can't see it, the outlets of the sample cell holder, the glass sample cell holder, are being covered with parafilm to keep out oxygen. Now we're almost done. We're ready to flash the solution. Hopefully you can see this a little bit better. The sample cell has been put in front of the laser, and the laser has been realigned to get the potential back up. And now we're going to go under data collection mode, which is described in the lab manual. First, make certain that the laser is steady, and then hold the flasher right up to the sample cell, but don't bump the sample cell. That's going to be very easy to do, and then you've got to start over. We're about to flash it, boom, there you go. You see an increase in absorption, which results in a decrease in the millivolts felt by the photodiode from the laser light. Here's the clever thing. You need 3 traces. The system is recovered, so charge up the flasher and hit it again. Boom. Alright, looks like we got time for one more. You do it successfully, you got your 3 traces, and you're done with this particular solution. In this case, after I flashed it again, I saw that the photodiode wasn't quite responding well. I didn't like what I saw right there. Hey, I had time to hit it one more time. And here we go. And I liked the way I saw this kinetic trace worked. And so now all I need to do is, I'm happy with the data, I'm just going to save it, perform the data analysis according to the lab manual.